Right. Hello and welcome to our talk on how we integrated continuous integration into our organisation. Now, we're not Redgate employees, so let me start out with that disclaimer. We don't work for Redgate, we're just satisfied customers, so we're going to tell you a little bit about how we used the TeamCity and Redgate tools within our organisation to streamline our development processes, what we got out of it, how we got the management buy-in to do it, and what we would and wouldn't do again. So, first of all, who are we? Well, let me introduce my colleague, Annette Allen. Annette is known to the SQL community as Mrs. Father Jack. She's currently writing a series of articles for Simple Talk on SSIS. In her spare time, she rides horses and trains their riders. Unfortunately, last year she had a little accident, but she's now recovered from that and looking forward to climbing back on soon.
And Dave Green has been working with SQL for about 14 years, from 7 to 2012, and he likes sailing, which is good as he lives near the coast. In January this year, he wrote an article on continuous integration, and that's what started this whole session. So, handing back.
Right, so that's us personally. Professionally, we're both database developers for a company called First Data Bank. Now, First Data Bank makes health products. Specifically, it makes data tools to help you get better health outcomes based on the health data that health services, etc. have. So it's things like medicines, treatments, making sure that you're getting the best treatment for the particular thing you've got. So there's a lot of data and analytics in there. For the purpose of this project, what it really means is that we're dealing with both bulk and real-time data, so BI and real-time data, and we're also working with not just data structures, but the data itself. So they're both parts form our product. So in this session, we're going to run through all the where we started from, what we wanted to achieve, what we learned along the way, and we'll show you how you can use the Redgate tools together with TeamCity continuous integration to as an approach for database projects, and the benefit that we got from doing that. So, have any of you got continuous integration in place for application development within your organisations? Okay, keep your hands up if any of you still use it for database as well. Much fewer number of people. Well, it's good to see that some people are using it anyway. So, before we started this project, we didn't use continuous integration at all. So this was a new departure for us. And we had two source control systems in use. We had Accurev, which was used for our software developers to keep their C# code in. Now, Accurev is not a particularly well-known source control system, at least it wasn't one I'd come across prior to joining First Data Bank. And it works in slightly different way to quite a lot of source control systems. I'll explain that as we go along, but it's not material. As long as you've got a source control system you're happy with, that's good. Our database products were based in a customised system. It had its roots in Visual Source Safe, but it had custom scripts and jobs put on the top of it to make it work with our database systems. And that meant that it wasn't actually very well integrated, it wasn't easy to use. So this project provided us an opportunity to solve these various issues, give us a cohesive approach for both database and application, and that meant that we would then have one place to go, knowing that we get the database and the data that went together without an awful lot of faffing about with dates and hoping that everyone had checked everything in at the right moment. So, as I mentioned a moment ago, we didn't have any design environment integration to speak of within the database design window, so we didn't have an SSMS tie-in. It meant that you were switching windows, remembering to script something out or press a button to put it into the source control system, which meant that you forgot or you did it less frequently. We also, because the system that we were using for database source control had been around for a while, it wasn't really designed to use the features that had been put into SQL Server since 2000. Now that's quite a while, and there's quite a lot of the advanced features that it wasn't able to cope with unless they could be properly scripted out easily. We were using a small number of servers to test on. So we'd check things into source control, and then we'd have an automated process which produced a test system. But if you had a number of changes going on that weren't related, those tests weren't automated, and it wasn't something that could be done in parallel. Effectively, everything went through in series. So this project gave us a good opportunity to step back, reappraise where we were, and we also had management support to actually make this change. So what did we want out of the whole thing? Well, we wanted a seamless integration process. We wanted it to be easy to use, to allow multiple developers to work together on the same product, the same piece of code at the same time. We also, because we'd been using NUnit-based testing, we wanted to be able to reuse that. We wanted to be able to run those tests on a continuous basis so that we knew quicker when things were going wrong. And you can't eliminate things going wrong, but if you know about it sooner, you proceed down the wrong line for less time. We wanted to change the way we were doing testing and to move towards test-driven development. Now, test-driven development is quite a change to the development team, and we knew that that was going to have impact, so what we didn't want was to be forced down that route. We wanted to be able to use it if we felt up to it, but unfortunately some of the pressures that you get from the higher echelons of the company to produce something quicker, faster, for less money, do sometimes mean that your testing suffers. So by not forcing us down that route, it wouldn't mean that we'd be forced to have that overhead. There's a follow-on session to this one in this room by Sebastian Main and Dennis on test-driven development. So if you're interested in that side of things, do stay on for that. I'm not going to cover it in an awful lot of detail for that reason. So we wanted a fully integrated system. We wanted it to be easy to use, because if it's easy to use, you forget to do it less, or you remember more, whether you're an optimist or pessimist. So if we have it all integrated, we minimise the window swapping. We don't have to think about it quite so much, and it happens automatically. As I mentioned a moment ago, one of the issues with the previous system was that our code and data were in different source control systems, so we wanted to integrate that. To get all this through, most of which you'll have seen are developer priorities, we needed to give something to our managers. And what they most wanted was visibility. So they wanted visibility of what we were doing on a day-to-day basis. They wanted to know when things were going well and when they weren't. And they wanted to get a simple read on progress. So we were thankfully able to implement that for them. So to put all that together, we used all those tools, which sounds like quite a lot, but all the Redgate tools come together as a bundle. So it all hangs together very well. Right, I'll now go through the reasoning for all of those in turn, and we can discuss them. So, we'll start with accurate source control. As I said a moment ago, this was something that we already had for use by our software developers. Now, we knew that Visual Source Safe wasn't a go-forward solution because Microsoft were turning it off. So, we decided that Accurev was probably going to be the one that we stuck with. Whilst we did consider moving to something like SVN, which is much better supported by the tools, we already had the licenses. So for cost reasons, we stayed with our existing source control system, which did the job entirely adequately. As I say, if we were starting from a blank slate, we'd probably have used something like SVN, which is very well supported by the Redgate tools and allows you to use things like TeamCity remote builds and Redgate migration scripts, which weren't available to us at the time. So for the demos in this session, I'm actually using SVN because it's slightly easier to implement on a laptop. As you'll have gathered, we used TeamCity continuous integration. It's made by a company called JetBrains and is a client-server based system. So you have the one server for the whole team. It goes and does its continuous integration, and it has a number of build agents to do its work from. We found a number of articles published by Troy Hunt on how to actually implement Team City within a database environment, which were very useful to us in working out how to do all this when we started. And there's a link to his articles at the end of the presentation. So Annette, do you want to take us through the Redgate tools?
As Dave says, we've got the Redgate tools, and the reason behind that was the company I used to work for before I joined the company I'm with now. I worked with my husband, who some of you may have heard of as Father Jack, and he is a friend of Redgate, and he'd got all the tools in, and I was using them and not thinking much about it. Changed company, didn't have them, and was like, oh no, what am I going to do? Suddenly realised just how much I missed them. So with the help of Redgate, we got some evaluation licenses, and I was showing my management just how great they are. Wasn't quite for long enough, so with the help of Redgate again, we managed to get some extended eval licenses, which they will do on a one-to-one basis. So if you need more time, contact them and they'll see what they can do. That gave me the ability to actually show the company what they could do and how great they were. So with that in mind, because we'd got them, they'd seen how good the tools were, we decided to carry on with them. As I say, Redgate were really great at helping us, not just getting us started, obviously, but as soon as we had any issues with setting up or getting this going, they were really quick to respond and to guide us through. And also, it's so easy when you've got one tool set. We obviously use source control, SQL compare, SQL data compare, SQL test, and we use Packager as well in our current environment. We don't go into Packager, but we do use it. And obviously Redgate come with industry recognition and reputation. It's a great company to be working with, so it's a win-win situation. The next decision we had was, did we go with a shared development model or a dedicated development model? Now, as Dave mentioned earlier, we previously worked with a shared development model and suffered with it because people were trying to change code at the same time and it conflicted and we didn't know which was the most up-to-date and it was all a bit of a nightmare. On the plus side, though, you've got lower licensing costs, only one copy of test data, and obviously it's in a managed environment, versus dedicated, where you work with your own box as a sandbox. I don't know if any of you went to Grant's session this morning where he talks about a sandbox development process. That's kind of where we got the idea from, because we saw that as a webinar a few months back. So you have your own box, you write your own code, you're developing against something that is a known good. You try it, you break it, you get a new copy and you carry on. You're not going to affect anyone else. And it integrates really well with AccuRev. Strange enough, we went for a dedicated version. I will now show you what we did. Now, if any of you were in the session this morning that David and David did on top 10 tips, some of this will be familiar to you. Anyway, the first thing we need to do is set up our source control. Now, if you can see here, get that working. My database has a little green icon next to it. That shows me that this is source controlled. Now, I've already set this up because I didn't want to take the time to do it in the session. I didn't want to use that time. However, I will show you how we're set up. So I'm using the AdventureWorks database, and this, oh, sorry about that. I will get this right. We're using the AdventureWorks database. It's linked to SVN here in this file path, and down below that we have the migrations folder. And if you wish to use migrations, that's where you set them up. Now, what migrations gives you is the ability to actually tweak things as you deploy it. So, for example, if you rename a column, the system will think you've dropped a column and recreated it. Whereas with migrations, you can say, no, this is the same, and do an alter script. Now, AccuRev doesn't work with migrations at the moment. It's something that we're hoping will come, or it's another reason that we could persuade management to change to Subversion TFS or one of the other ones that's fully supported. So unfortunately, we can't use that, which is a shame. And finally, you can see down here that we've got a dedicated database. Okay, so the first thing you do when you get set up, and on a daily basis, or more often if you need to, is you do a get latest. So I want to make sure that my source control is as up to date as possible. So I've got everybody else's changes. Now that while that's going, we also source control static data. So anything that's a dictionary table that isn't going to change much, we source control as well. It does sometimes slow this down, but it does mean that everyone's using the same set of data if things aren't going to change very much. Now, we can see down here that my demo table is in my source control, and I don't have it locally. So I want to get that. So I'm just going to click on Get Latest, and it's going to give me that latest version on my database. Should only take a second or two. Okay, so if we go back to our database and refresh it, you can now see that our demo table is in the database, all ready for us to use. Okay, so now we need to make some changes and source control them. So here I have a couple of changes. I want to alter my table. I'm going to add a hair colour column because everyone needs to know what colour hair everyone's got, obviously. So we'll just run that. And I'm going to add a table as well. So we're going to add a dependence table. Okay. Now if we look over here, we can see that our employees table has a little blue bubble next to it, which shows that we've got changes that aren't in source control. Obviously, my new table hasn't shown up, but if I refresh my table list, that's going to be available to me. Before I source control it, or before I commit it to source control, I need to test it. Now, as Dave said earlier, the next session in here with Dennis Lloyd and Sebastian Main talks about test-driven development, and they do actually go through how to set up a test in SQL Test, and it's really good. I'm not going to. I'm just going to use some standard tests that come with a package that's a built-in function called SQL Cop, which basically checks for generic things. So I'm going to run this, and hopefully I'll get lots of green ticks next to it. We have one that's gone red. So we have a test that's failed. If we look over here, we can see that if I were to move that all the way over, which I'm not going to do, it gives us the whole URL as to where we can find more information as to why this has failed. Now I know this is a known bug with SQL Cop and the AdventureWorks database, so I'm not worried about it. I know that's going to fail, and it doesn't bother me. Now normally when I'm writing code, I'd create my own SQL tests and test everything thoroughly before I go any further. Let's just assume I've done that and it's all okay. So we're going to go back to SQL Control, and I want to commit my changes. So it's now going to check what I've got to change against source control, which doesn't usually take very long to do. Famous last words. While it's doing it, when you do promote it, you need to make sure that you've got some kind of meaningful comment. So I'm going to put, if I can type, which I obviously can't today, a meaningful comment in there. Now, if we have a look down here, we can see, hang on, I'm just going to rearrange my window because I've rearranged it wrong, that we've got two versions of the employee. So this left-hand side is my version, the right-hand side is the source-controlled version. So if you scroll down, you can see, is that highlighted? Yeah, that we've got hair colour on the left-hand side that isn't on the right. So we can easily see what changes we're going to promote. And here we've got dependence table, which I've got, and that isn't in source control at all. So I can now promote that and put that in source control. So this is now just telling me which step we're at, how long each step takes, and that's the very, very latest version, which took me a bit by surprise yesterday when I saw it. But that's now committed in source control. Now the way we work is we have a separate step. So we promote everything to source control and then promote it again to the shared development environment as a fail-safe. So to do that, we just run a batch file. So now that's ready for Dave to take you through continuous integration.
Thank you, Annette. Right. So, as Annette has just said, we've found it very helpful to have separate areas to segregate out the different levels of development. So when you're developing in a large team, you tend to have bits of code that are at different stages. You've obviously got the code that was developed last month and works, and that's ready for deployment. But you've got bits of code that are still in development. Maybe you've got 3 different bits and they're none of them actually quite ready to be shipped. We found it very helpful to have these separate areas to separate out what's being developed from what's nearly complete from what's ready for deployment. Now in Acurev those are streams, but in SVN you'd use branches to accomplish the same thing. So they're source control areas. They're not anything to do with the database, but they're how you manage the database objects within source control. So we can move code objects between them. So we'll start out by developing locally, and as you can see that's actually done on your local developer workstation. So that's what Annette's just been doing. When she checked it in, the batch file she was using was promoting things up to the, well in fact it was promoting things up to the integration area. Normally we promote it up to the shared development, which would allow your colleagues to work on it. So it takes it from your local workstation to an area where everyone can work on it. That means that, for example, you might have a database developer and an application developer working together, but not necessarily on the same machine. You might have a tester doing some tests for a database developer to then consume. So it's in the shared development area that happens. So obviously you've got bits of code in the shared development area that have been started and not completed. You've got some that are ready, that are complete. You've also got some, of course, that have been started, got halfway through, and actually it was a bit of a blind alley. So the integration area is where we put all the bits of code that we want to get into a build together. So that's the first time that we actually introduce it to the CI server. And it has automated testing of all the work that we've got together, and it's the first time that we get the automated integration testing. So whilst you will have done some testing locally, and there will be some testing that's done at the shared development level, the integration area is the first time where we put it all together and we have our actual set of tests that are going to then form the decision for whether we take that into the product or not. That integration area has a tendency to encounter test failures. That's normal, that's expected. The next area is acceptance, and that should only be working code. So if it's got through integration, it should always hang together quite well. Again, that's the ideal. This is again an automated build of acceptable code, and that's where the product managers get to decide, are we going to actually take this forward? Is this what I want to take to the customers? Once that decision's been made, we move to staging. So in integration, we'll have very small bits of work. It's as soon as it's ready for integrating into the rest of the package. When it gets to acceptance, it's something that makes business sense. And when it gets to staging, it's something that makes sense to release. It's a set of new features for the new release of the product. So that's the co-promotion model that we go through when we're looking at the continuous integration side of things. And you can see that integration, acceptance and staging are all based in the continuous integration server. And we actually run the same tests at each of those stages, just to make sure we haven't lost anything along the way, nothing's broken, anything else untoward happening. In the final stage, we actually build a release package, and that's what we use SQL Packager to produce. And that's what we then eventually deploy live. Now, you may find that you'd use a release script at that point rather than a package. As I say, that just depends on exactly what your infrastructure is. So, next on the list is a demonstration of how we're actually using TeamCity. So as I mentioned a little moment ago, TeamCity is a server client system and it's web-based. So in this instance, I've actually hosted it locally on this laptop, but obviously in the normal development environment, it's actually hosted on a server, and we all connect to it. So TeamCity has its work allocated in areas of project. Now, a project is, as you would expect a project to be. It is the standard definition you're used to in the business. It's a lump of work that you're working towards. In this instance, we've called it AdventureWorks because that's the database that we've been looking at. Within that, I've got integration and acceptance builds. I haven't got a staging build here because it's not really material to what I'm going through, but the same principle applies to all three. So from this initial screen, what can we see? Well, we can see that it's currently got a little green dot. That means it worked last time we ran it. We can see the number of tests that passed. We can also see when they passed. So did this work relatively recently, or has everyone been on holiday for a month? You can see the build duration as well, which is helpful for working out whether you should go and get a cup of coffee or come back tomorrow. We can see we've got some pending changes here. Now, in our development environment, what we actually do is we have the TeamCity runs triggered automatically as soon as you promote something in. Because this would only take 35 seconds to run, if I'd done that, it would have happened whilst I was talking on the previous slide when Annette checked something in. So, what I will do now, you can certainly see that the changes that Annette committed here are ready to be run. So I'm going to run that now, and let's add it to the build queue, and it will go and run that build. So we can now see that it's running, and it's going to take a few seconds to run. Whilst that's happening, let me just show you how all that hangs together. So, oops. We can see that we have two configurations here, acceptance and integration, and they both say they're based on database build. Now, database build is actually a template, and that's because the areas are so similar that we wanted to have that to make sure that it was the same, with a couple of subtle changes. From using templates, we can use parameters to differentiate which source control area it's pointing at, which server, which database, but the processes in terms of how it actually runs remains the same. So if we look at the build steps, we can see that we're going to drop and recreate databases. Gives us a nice clean starting point. We're going to update our database schema, update our source control data, so that gives us everything as we have in source control. We're then going to run our unit tests and retrieve our test results. Now, as I say, this is a slightly simplified version for this demonstration. We do have additional n-unit tests and package of steps in our main build. So if you're using an existing test framework, you'd obviously call it at some point in this as well. So you can see from the build steps here that we're actually using quite a lot of command line steps. Redgate are actually in the process of putting together a plugin to make this a little bit easier, but the command line steps will show us the process that it's all going through. So I've actually copied those out into Word so they're easier to see. So the first build step we're looking at is the drop and recreate databases. And we can see that's actually using SQL command, which is obviously a standard MS SQL process, to run a .sql file. Now you'll notice that some of these are actually variables. So you've got percentage TeamCity build checkout directory. So that's wherever the TeamCity server has seen fit to put the source controlled files. Which means that I can use the one path there to specify things. Whichever build agent, whichever machine it's running on, I'll get the files in the right location. I'm also specifying a server based on a parameter. So that's going to be the SQL server that it executes against. And by making it a parameter, I can have multiple of these working at the same time. So let's just have a quick look at what is in the SQL file in question. So this is the integration version of that. Let me just make that a little larger. So what we can see here is that we are going to essentially drop our database and recreate it. Now, a step that we've found very useful is to actually put the database into single user mode first. That allows us to get round any problems caused by someone having a look at the the database under test, leaving the connection open, and all of a sudden you can't drop the database. So by putting it into single user mode, we've found it helpful. There are instances where you need to be aware of that, and particularly we've turned it off in one build where our testers have found it helpful to keep their test data. If they're doing a manual test for any reason, then we would be shooting ourselves in the foot if we kick them out. The other thing worth noting on this screen is that we are putting the database into trustworthy mode. So what that's doing is allowing us to then apply the unit testing framework, which uses a CLR object. We won't ship that because it's a test framework, but we do use it when we're creating our TeamCity integration areas. So that's the first step, and that just gives us a clean place to start from. Next thing we do is we update our database schema. Now this is based on the SQL Compare 10 command line version. So we're pulling in from a scripts database, which is just wherever our source control has been checked out to. We're applying that to a database on a particular server, both of which are parameters. And we're using the sync switch to allow us to actually update the database. We're then doing something very similar with any source controlled data. Now we don't source control all of our data because some of it is authored all the time, but any reference data, the things that don't change, we tend to keep in source control. It means that all our systems are running off the same data, and obviously whilst you'll use some test data, the majority of the reference data doesn't change. Things like genders and so on don't routinely change. As I said, the command line switches look very similar, and that's an intentional move on Redgate's part to make them easy to use. So that's the data and the schema in place on a fresh database to allow us to start our testing process. So if we failed thus far, it's something to do with either the schema not being consistent or the data not fitting into that schema. Now that does happen, particularly if you've had a change to a stored procedure or something, and so things do fail at that point, but it's relatively infrequent. The next stage on the to-do list is to actually run our unit tests. Now the whole point of our using continuous integration, or one of the points, was to get us to be able to use test-driven development, but also to continually unit test things. So we want to run these tests. The way we do that is we're actually calling a stored procedure. The TSQLT framework, which is what's used by SQL Test, is actually all SQL based. So we use SQL CMD to connect to the database server and run our stored procedure. Now I've actually put it into a separate file here, and that is simply so that we can test for its existence. We sometimes have databases which don't actually have any unit tests in them, particularly where it's reusing an existing NUnit framework for that project's testing. So it doesn't always exist as a testing framework, and there you go, you can see it a bit better now. And by testing it with an if exists, it just means we don't get a failure if there is actually no testing framework. But the meat of this one is just the execute line. So we're just running a stored procedure. Now that runs all the tests in the system. You can run particular test classes. So you can tailor this slightly if you don't want to run all of your unit tests. There are various reasons why you might do that. If you've got a database that serves two purposes and you're actually only wanting to test one of those, or conceivably if you've got different types of unit tests you want to run at different stages in the process. The majority of the time we just use run all. So let's just see what TeamCity's been up to. Right, so we've now got a test failure. So we can see there that one of our tests has failed. Now, if we had stopped our build process at the end of the steps I've just run through, we wouldn't get that nice message. What we'd have to do is, what we'd get is we just get a red dot and build failed. And what we'd have to then do is go into the build log and scroll all the way down past the bit where we're using the SQL compare command line. We'd have to scroll all the way down through these table objects that we're rolling out, all the way down through the data changes. As I say, we haven't got much source controlled data here, but we've got a little bit of it, and down to our unit tests. And it's at this point that we'd be able to see our execution summary, which would tell us that it had run 5 tests, 4 of which succeeded and 1 of which failed. And we'd even be able to see the error message that we had when we were running the tests locally. That isn't very user-friendly, and people don't dig into that. So what we actually have now got is a final build step which retrieves those TSQLT test results, and it outputs that in a format that TeamCity can open, can use, and that gives us a lot more usability in terms of working out what tests have run and what tests have failed, but also whether they've failed recently, whether they're taking longer than they used to, and other information like this. You can get graphical feedback and reporting on your unit tests. So this is quite a particular step, and one thing I will say is there's a book running around outside. Just ask one of the guys in red for it, which is the continuous integration for databases using Redgate tools. I believe it's also available through their website. That details all these steps, so there's no need to copy everything down. What we're doing here is we're loading the test results into an XML file, and we're using a store procedure to do that. The store procedure in question is this one here. The only reason that I've put this out to a separate file is because we need an XML output. Now, if you don't specify that you want XML mode on, then you get the first couple of thousand characters of your XML message and then nothing. And that truncation means the TeamCity can't read it back in. So we need to specify it as a separate file. In terms of what that gives us, if we go to our integration area, and we can actually see, first of all on our overview, which test failed, with the detailed error message that we had. We can also see, if we go to our tests, all the tests that ran, and we can search within those for particular test classes. In this case we've only got the one test class, but the principle holds. And we can also dig into that to see how long each test took to run, what the trend is, whether the test is taking longer or less time to run. And we can go into the particular error message on there. We can also see which build things failed on. If you're only getting a success or failure for the whole build, you can't see whether your test failure has been recently introduced or has actually been with you for 6 weeks and someone's been ignoring it. So, what can we do about this test? Well, when Annette was demonstrating earlier, she noted that it was actually a known issue. So we can investigate this one. Oops. We can investigate it here, and we can say, right, I've investigated this, and I'm going to mute it because it's a known failure. The concept of muting tests is that the TeamCity system will still run all those tests, but what it won't let that test do is, if that one test fails and nothing else does, then it's not going to fail the whole build. So this means that if you've got an issue where someone's promoted a test in advance of the code actually being written, or if the test is an area of functionality that actually the business doesn't have as a priority to rectify the issues with, then it's not going to stop everything else proceeding. You don't have to deal with unpromoting things or demoting things. So we've muted that project wide. You can just do it for this particular configuration. If it was something that was, say, 32-bit only, and you wanted a 62-bit builds to still run it. In terms of how we unmute it, there's particular methods. So we can say, actually, I don't mind about this one for a week. We can say, I want to do this only when someone checks it, or the default option, which is when the test passes successfully. So what that means is it'll still run it, and until it passes, it won't regard that as a critical failure. But as soon as it passes once, it's then got to keep passing, which is very useful when you are looking at test-driven development. So again, we have a comment window which allows the information to be shared with the rest of the team. So we'll put in a suitable comment there. So why are we muting this one? So we'll save that one. Now what we can now see is that we have two little icons appeared. The one on the left, which looks like a little eye, shows that someone's been looking at it. The no entry sign is to say that it's muted. It's not something that's being looked at the moment. So that information is actually available to anyone who uses the TeamCity interface, and you can see information there as to exactly why it's muted and when it was muted and who did it. Right, so with that test muted, we can rerun. Excuse me. So that is running, and you can probably see up here we've now got a blue circle next to the agents. Now a square even. What that represents is that our agent is busy. Because this is a laptop, I've only got the one agent, which is the laptop itself. In our main build environment, we have many more build agents. Now, build agents are the worker bees. They're what actually goes and does the testing, what does the building. So you might have the build agents on... Notice the notifier box that was just there. I'll come back to that in a minute. You might have multiple build agents on, for example, 64-bit, 32-bit, maybe a different release of SQL Server. So you might be testing against multiple versions if you've got to support, say, the latest 2 versions of SQL Server. You might even have some slightly different scenarios you want to build. So we've got one that tests whether it's working on a locally deployed instance, and one that looks at a remote SQL Server just to check that everything's working there. Your needs will vary. The agent itself is what can happen simultaneously. So you've got the physical configuration of the machine that it's doing it, and you've also got the fact that each build agent can only do one thing at a time. So if you've got multiple projects, you want to run them in parallel, you need multiple build agents. The free version of TeamCity comes with the ability to have up to 3. So that means you can actually do quite a lot of that without having to invest significant money to do so. Right, so...
yeah.
Do you need to install the red gate on each agent? Or?
Yes, the red gate tools are installed on each build agent, and having the red gate tools on there is not as costly as it would be to have it on each developer workstation. You obviously need the developer copy to actually get it working, but Redgate and TeamCity both do continuous integration licensing, so that means that it is quite cost effective to have additional build agents. As for the exact prices, talk to one of the guys in a red shirt, but it's not prohibitive.
And have a stress ball.
Yeah. At the back.
This tool is helpful for remove unwanted objects from database, to identify unwanted objects.
So, unmonitored objects?
Unused objects. Like if you use a customer table, not used for so long, if you want to remove that, how do you do that?
Right. Well, you do that within your database source control. So you'd effectively, going back to the application here, you would right click and delete from your database.
Yeah.
When you then go to source control, you'd be committing a dropped table, which commits to the source control system that that object is removed, and then when all your tests run, if they've got tests on that object, obviously they'd fail, but if you've removed the tests as well, then that will proceed. And because we're starting from a blank canvas each time with the drop and recreate, it allows us to actually have a clean starting point. We don't have that object, so when it's dropped out of source control, it won't ever get created. here's a challenge for you.
Yeah, this is going to be a laugh. Everyone duck. Ooh!
You wouldn't mind.
Sorry, I'm like,
And one more question.
oh God, let me get one of these.
This tool is helpful for capturing deadlocks, like mutual exclusion or deadlocks. Like if you're using multiple records, try to fetching one off table or one off there, creating deadlocks. How do you capture?
You probably wouldn't through this, but because basically what this is doing is testing that everything builds okay. If you want to catch deadlocks, I would think, and the guys in the corner over there can probably answer, you'd use monitor.
So we'll pick that one up afterwards if you want. So, our test has now, incidentally, you can see here that all the history of the builds, and I've done this demo a few times, so you can see the history on there. But if we go to the main screen, we get a nice green window saying that all these 4 tests passed. We also get the fact that we've muted one of those tests nice and visible, so we can see that there is something I'm not running. And obviously I can click to go into all the details on that. So, at this point, because you've got a green integration build, you can then have the decision as to whether you would promote that code up to the acceptance area. Does it make sense with other bits of code to promote it, or is actually some more work necessary? So, because as you may recall, the acceptance area holds things that are ready for acceptance by the business, but the integration area holds smaller bits of code. So it may not make sense to promote this one change on its own. You may want to wait until something else has been put in as well. So, whilst we were running that, I think we noted a notification window come up. So, in terms of how do you know when this stuff completes, clearly you don't want to have your web browser window open all the time. You may need to when you're actually monitoring something in detail, but most of the time you don't actually want that window open. So there's a tray notifier that's built into TeamCity. So that pops up a notification, and you can train it as to when you want to be notified. So do you want to be notified on every build failure, every build success, or, I mean, in our environment, I have it telling me about any failure in acceptance, because that's more serious, or do I actually want to have it in the, for integration area, I just have it telling me about my failures. That's very good for for us as developers, and we can be notified by tray notifier, by email, by an instant message client. All of those are possible straight out of the box with TeamCity. But one of the things that we originally set out to do was to get some management buy-in based on giving them some visibility. So, this is the screen we use to display the status of all our builds, or in this case, the selection of them. So this is just a spare monitor that we keep within the development area. And actually you can see we've got an open plan office. So it's very visible. It's on the end of an unused desk. Some places would have it mounted to a wall. The idea is that it's not something that you hide. You're actually making a song and dance about it effectively. That this is the status of things, and you can see what's running. So let's just pop back a bit. You can see there we've got a little running icon to show that something is actually happening, and so people can see the status of what's going through. That's a nice green screen. It's not always that good, but we try and keep it green. Usually when it's green, it's for management, so that everything's good, nice warm fuzzy feeling. When it's red, it's for the team to go and sort out. So I'll hand over to Annette to talk about some of the issues we had from a developer standpoint.
First thing we had to do was work out how to integrate all these changes into our development team. That meant a change of mindset for the team. They were working in a different way. We wanted them to be writing tests early on, a lot more tests, and do a lot more stuff that they just weren't used to, and work better as a team for a whole project team. We gave them a 1-hour integrated design environment training just to help this, but it was still an issue. The workflow changed as I said, the team had to work a lot closer together. So the developers, the software developers, the SQL developers, the testers, all had to talk to each other to make sure this happened. We also deal with data. We actually sell a data product as well as a schema. So we had to look at how we could test against live data, which was an issue. And we implemented all of this with a change to an agile environment. So we basically threw everything up in the air and changed everything in one go. Fun times.
But it worked, so we expanded it. As we built on our successes, we expanded it, and we came up against a couple of little niggles. Contention was one, where we introduced more build agents to allow us to run more things at a time. As you build more tests, the actual runs take longer because there's more for it to do. So whilst in a small development you might only have a couple of hundred tests, once you've been going for a little while, it builds up into the thousands, and that can mean that it takes 20 minutes, half an hour to run. If you've got a number of projects running, you can be sitting in a queue for a while. So we found that putting more build agents cured this. There you go, multiple build agents. As I said in answer to the question earlier, the licensing side of things helps you to actually be able to justify that. Once you're at the stage where you need more build agents, usually you can get the support to actually have the relatively small cost of the additional licenses. The free version of TeamCity gets you up to 3 anyway. So switching between projects, if you're anything like our team, you're actually pulled off onto sorting out a more urgent problem on a fairly regular basis. We found that you can switch between source control databases, all of which run through TeamCity very quickly. You just simply have them all source controlled to different repositories within the one local install of SQL Server. That works very, very well. You do need to think a little bit about when you're promoting stuff though, because clearly you don't want to leave the database in a state where someone else can't then pull it down and build a working database. So you need to think a little bit. But from all these complexities, some lessons learned. Security models. When you're working with this sort of rapid deployment, you want to find the problems earlier. That's the whole purpose of continuous integration. So we found it very helpful to have our continuous integration system as close to live permissions as is practicable. Ideally, you'd be locally developing under those same permissions and same restrictions. However, that has proved a more difficult thing to get adopted. But it is a best practice, so I suggest you work towards it. Getting all this sorted out is a change. Whilst you're getting used to that change, it takes a bit longer to do. Shouldn't be a surprise, that one, but it caught us out. So there you go. You need to actually plan a little bit more in the project time to allow you to do it. You get used to checking your code builds well frequently, which is a good habit. So you're producing better code. And because you're checking in smaller lumps, the code that you're going back to fix isn't as stale as it might be as if you're only doing the test once a week.
Okay. We needed more build agents. We call worker bees. Worker bees are the build agents. First time we added a new project in, suddenly our build time went from half an hour to 2.5 hours. So we very rapidly got some more. We need a build master. We christened our build master a Jedi master. So someone who was in control of when promotions happened and when builds happened, to make sure that things went up atomically, to make sure that something didn't go up that was going to affect other people. It does drive a change in the way you develop. So you write all your tests first, you code, then you get the changes done, and it does improve things. And it also, the visibility gives you the chance to show what a great job you're doing. Kind of if things aren't going well, it has the opposite effect, but we don't dwell on that. This came to bite me last week. As Dave said earlier, you have to set your trustworthy on for the CLR for the SQL test to work. I created a new database, source controlled it, did my get latest, and it blew up in my face. And I was like, oh, what have I done? And I hadn't done that.
So, one of the things we did discover halfway through is that Redgate put the version of their tools into the path. So it's installed in program files /SQL compare version 10. Great. Now what do you do if version 11 comes along? Well, if you're anything like us, you forgot to use templates. So you have to go through and modify each step in each build. We discovered templates after this. I would strongly recommend them. rollbacks. SQL Source Compare is a way of using your source control system with SQL Server Management Studio. It's not a source control system in itself. If you need to do a rollback for any reason, then use your source control system. It's what it's there for. If you try and do it within the tools, you can do it, but it's a little bit suboptimal. So use the source control system for what it's good at. Use the integration for what that's good at.
Make sure that you put everything up together. Like I said, if you change a store procedure that uses tables, make sure that you put all the tables up at the same time, otherwise it tends to go bang. Not very good.
So from all those lessons, would we do it again? Let's have a quick look at some of the things we've learned from implementing it.
Software development cycle was definitely shortened. We can get projects out much, much faster. It's a bit like Simon said in the introduction this morning. We've had the same issue, same solution even, not issue. Our project, the last big project we did, took 2 years to release. The latest one's taken 6 months. There is also a perception. It is only a perception that bugs are found earlier. Basically, we find the bugs when we're developing rather than at the user acceptance stage, which is obviously a good thing.
We found those two items mean that we're working much closer together as a development team. So your testers, your application developers, your SQL developers are all cooperating. They're working on smaller bits of code, so they're talking more often. And that means we've got a positive feedback loop. Everyone's talking, they're getting closer relationship. The whole thing works better. We also have a much better understanding of what each other's problems are. That closer relationship actually helps us to get better buy-in from corporate project sponsors. We're talking to them more as well, because we're dealing with smaller lumps of code. They can see progress better, so they're getting the better buy-in. We've actually found our return on investment has been very high, not because we're doing more code, but this method allows us to do less maintenance, to do having less conflicts in the work that we're doing. Because it's smaller lumps, it interacts better. It's enabled us to have a larger team working on the project with more separate lines of development than might otherwise be possible. As I mentioned, we moved to agile development at the same time, so we can't be 100% sure how much of the return on investment is due to which move. But we didn't have to roll out continuous integration to other areas of the business, and we've actually now rolled it out across the whole, all developments that the company does. We got our new product of significant complexity to market in 6 months, whereas previously it was taking us 24 months to accomplish the same sort of thing. So, as I say, we've rolled those out to the rest of the business. So would we do it again? Yes, we would. So that's sort of what we wanted to cover in this session. Now's your opportunity to ask any niggling questions you might have. Those are the resources I mentioned earlier. So any questions? Oh.
How are those